See, we can use E or we can use V, one and the same thing. We can use V also, we can use E also. E means EMF, V means voltage, not a much difference. Okay, so let's see what we have. We'll solve it one by one. We'll make the diagram first. I'll just simplify the diagram for you people. First step, we will apply step 1. Apply E is equal to, you can use E, you can use V, no problem. E is equal to E naught sine omega t. Okay, this is our resistor circuit. This is our resistor circuit, two resistor circuit. So what we have? This is our inductor. This is our, sorry, this is our not inductor, this is our resistor. Once more, yes, we have a resistor, not inductor, we have a resistor like this. Okay, and we have alternating current source. That's your diagram. That's it. This is your diagram. This will be your alternating current source with this symbol like this. Okay, now first step will be E is equal to E naught sine omega t. In step number 2, in step 2, you are going to find you are going to find I using E. How to find I? So I will be equal to, see, V is equal to IR. What we have V is equal to IR. That means I will be equal to V upon R. Here the role of V is played by whom? It is played by E. So this will be E upon R. What is E? E will be E naught sine omega t upon R. What is E naught upon R? If E upon R is current, then E naught upon R will be I naught. So that will be I naught sine omega t. Okay. Step 3. In step 3, we have 3 things. First, we have to find phase relation. Phase relation means what? What are relation between EMF and current? This is EMF and this is current. See, E is equal to E naught sine omega t and I is equal to I naught sine omega t. Both will start together, both will reach peak value together, and both will end together. That means what? That means current and EMF are in phase. Okay, then what we have? Then we have phasor diagram. Then we have phasor diagram. Phase relation, then we have phasor diagram. In phasor diagram, what will happen? In phasor diagram, current and EMF will be in phase. If this is current, and if I am representing EMF by this blue one, so they both will are in phase. They both are in phase. Okay, and what about phasor graph? What about phasor graph? If you study about the phasor graph, if you study about the graph, if you study about the graph, in this graph you have either you have alternating current, or you will have alternating EMF versus time. So for current, I will represent it by a red one. So it will be like this. And EMF, it will start with current, it will end with current, it will reach peak value with current. You can make it bigger also, you can make it smaller also. Okay, this red one will represent current and this blue one will represent EMF. Then we have the next step. Then we have next step to find first one was to apply E is equal to E naught sine omega t. That will be common for every circuit like L, C, and R. And the second one we are going to see current. What is current? Current will be E upon R, because V is equal to IR as per Ohm's law. That means I will be equal to E upon R. In place of E, we are substituting E naught sine omega t. So what is E naught upon R? E naught upon R is I naught. Okay, I naught sine omega t. Then step 3 will be phase relation. In phase relation, we are going to check these two equation and we'll see which of these quantities are leading or lagging with each other. But as per our conclusion, we'll see that there will be no leading and lagging between EMF and current. Then we studied about the phasor diagram. What about the phasor diagram? Phasor diagram, yes. If you are making current slant, you have to make E also slant, because there are no leading and lagging between them. Okay. Then the last one was then next one was graph. And here only I'll explain the villain. What is villain in this case? In this case, as this is a resistor circuit, villain will be resistance. So the step 4 will be resistance. The villain of alternating quantity. Step 4, villain. Who is villain in this case? Resistance. As per Ohm's law, V is equal to IR. So R will be equal to I upon V, right? I upon V. V means E. So what is I? I will be I naught sine omega t, and E will be E naught sine omega t. See what we have? V is equal to IR. That means R will be equal to V upon I. Not I upon E, E upon I. So what will be our resistance? Your resistance will be equal to, see, V is equal to IR. That means R will be equal to V upon I. V means E upon I. So this will be equal to what? This will be equal to E is equal to E naught sine omega t. I will be equal to I naught sine omega t. That means sine omega t will get cancelled, and you will get the value of resistance as E naught upon I naught. Okay, we don't have fifth step here. Why we don't have fifth step here? Because we have to plot villain versus frequency. See, if you check this equation, we don't have frequency quantity. So how you will plot this villain versus frequency? So there are no chances of having step 5 in only in this case. Okay, but yes, we have the next one. We have the power one. So 5 steps we have total here in this case. First one was E is equal to E naught sine omega t. Then we will find I using E. Then we'll see step 3, that is phase relation, phasor diagram, and graph. In the last and next one will be resistance. How to find resistance? We'll use Ohm's law. Ohm's law states that V is equal to IR, but R will be equal to E upon I. E is E naught sine omega t. I is I naught sine omega t. Sine omega t will get cancelled, and you will get E naught upon I naught. Next. Next, we have to find power. Power. What about power? Step 6. Step 6, power. The formula for power is V into I. V into I means simply E into I. V into I you can write, or you can write E into I. We know that in this case, your E value was E naught sine omega t, and current value was I naught sine omega t. That means this will be equal to what? E naught I naught sine square omega t. This is our power. E naught I naught sine square omega t. We have to find average power. We know the formula for average. Yes, what's the formula for average? Right in this marker. Yes, the formula for average power was integration of p dt over integration of dt. You can write with respect to t, you can write with respect to theta also. Okay, limit will be from a to b. Let's see what's the limit. Limit will be from a to b. So if you check this thing, so what you will have, you will have power is equal to integration of 0 to time period capital T. This will be E naught I naught sine square omega t over integration of dt 0 to t. So this will be equal to E naught I naught integration of sine square omega t upon, you have integration of dt will be what? That will be t, and this will lie from 0 to t. So this will be equal to E naught I naught sine square omega t. You know what's the integration of sine square omega t? Yes, you can check sine square omega t. The value of sine square omega t will be equal to sine square omega t integration. And see, this are constant. I'm keeping it here, and here you have sine square omega t. If you check the value of sine square omega t by integrating the factor, you will get value of this as E naught I naught upon t multiply by t by 2. So this t and this t will get cancelled. You can check the integration of sine square omega t. You will get t by 2 by integrating and substituting the value of, by integrating and putting the limits from 0 to t. So you will get E naught I naught upon 2. So can you write E naught as E naught upon root 2? Yes, you can write. Can you write I naught as I naught upon root 2? Because root 2 into root 2 is what? It is 2. So this will be equal to, what is E naught upon root 2? E naught upon root 2 is ERMS. What is I naught upon root 2? I naught upon root 2 is IRMS. So your average power formula is this E into I, that means ERMS into IRMS. The only catch you have to remember is integration of sine square omega t. We can solve this thing, but no need of this, because this can be asked for hardly 3 marks. And for that, these steps are enough. If you are solving this integration of sine square omega t, you will get value as t by 2. T and t will get cancelled, and you will get the further value as average power will be equal to ERMS into VRMS. Okay. And 1 upon root 2 is what? 1 upon root 2 is 0.707. That is written here. Next one. Next is the case of inductor. What in the case of inductor? Same steps, same 6 steps we are going to follow. Same 6 steps we are going to follow. First step, we have the common step, that is step number 1. And in that first step, what we are using apply E is equal to E naught sine omega t. That's it. Yes. Two resistor circuits. So here, so two inductor circuit. Inductor, you will make a coil. You have a diagram. you have a coil, you have a diagram, you have a coil, okay, you have diagram, you have a coil. So first step, that's it. You'll make a diagram and you will write the equation. What about the second step, step number 2? In second step, step number 2, you will use I, sorry, you will use E to find I using E. How you can find, check in the last lecture, that is yesterday's session, we studied that your induced EMF formula is L di by dt, L into di by dt. So by variable separable method, you can write E dt is equal to L di. Integrating both side. So before integrating, we can write here as in place of E naught sine omega t. That will be equal to L di. Integrating both sides. So therefore, E naught sine omega t dt will be equal to L integration of di. Limit will lie from 0 say t. Limit will lie from 0 say from 0 to, the limit will lie from 0 to I. This limit will lie from here 0 to t, and here limit will lie from 0 to I. Now what? Integration. So constant will be out of the picture. I'm writing here. Yes, the constant will be out of the picture. What is constant here? E naught. What is the integration of sine omega t? Sine omega t integration is cos omega t. It is minus cos omega t. And this omega t integration will be omega upon, and this will be equal to what? This will be equal to L into I. Integration of di will be what? It will be I only. So for finding the value of I, you will use E naught upon L omega into minus cos omega t into minus cos omega t. Okay, see, if you check, this current is in cos omega t and this EMF is in sin omega t. We can't find the relation between them, but we have a trigonometric formula. We have sin 90 minus theta is cos theta. Once again, see, this is in sine, this is sine function, this is cosine function. If in the next step we have to find the relation between them, what we have to do? Yes, we have to find the relation between them. It will be a complicated case. So here what we will do, in cos omega t, we will convert this cos omega t into sin omega t. How to convert cos omega t into sin omega t? We know that sin 90 minus theta is cos theta. So already we are having E naught upon L omega multiply by what in place of cos omega t, sin 90 minus theta. If I write theta minus 90, so minus sign will come out. Once again, see, sin theta means omega t minus 90. Sin 90 minus theta is cos theta. If I am writing theta minus 90, I will take minus sign out. So this will be what? This will be E naught upon L omega. Now it will be easy for you people to distinguish the relation between them. Yes. Next, check this one. If you check, you will get E is equal to E naught sine omega t, and I will be equal to E naught upon L omega into sine omega t minus 90. That means what? This current will be lagging by what angle? By angle pi by 2. Pi by 2 means what? Pi by 2 means 90 degree. So I hope your next step will be cleared. Phase relation, phasor diagram, and graph. Let's check the next one. This I is equal to I naught L omega sine omega t upon pi by 2. Remember this case, and this we will be using further. I'm taking you to the next slide. Yes. So our picture ends here. I is equal to E naught upon omega L into sine, say sine theta minus 90, omega t minus pi by 2. Now the next step means step number 4. Yes. In step number 4, what we have? In step number 4, we have step 3. Sorry, step 3. We have to find first phase relation. Phase relation. If you check current and EMF, they will not be in phase. Not be in phase means current lag EMF by how much angle? Angle 90. Or EMF lag current by pi by 2, that is 90. If you check the next, this is phase relation, then next one will be phasor diagram, and after that we'll be having graph. This is phase relation, this is phase relation, this is phasor diagram. What do you mean by phasor diagram? Phasor diagram, what you will use? This is phasor diagram. Here you will have current or EMF, and here you will be having time. So current or EMF, and here you will be having time. So what you will use first, if you are writing EMF first, sorry, phasor diagram, phasor diagram is will be like this. Phasor diagram will be like this. If this is current, always remember current will be here only. This is current, this is the fixed, this will be the fixed position of current everywhere. Current and vector length will represent the maximum current, maximum peak value. So I will represent it by I naught. What happened here? Current legs means it will lag behind, and we are always moving in anti-clockwise direction. So where will be the value of EMF will be somewhere here. EMF will be here. This is E naught, and angle between them will be what? It will be 90 degree. Okay. Current, I'm making some mistake. Current leg and EMF leads. Here EMF leads. Okay. Phase relation, phasor diagram. Then what? Then we have graph, a small graph. What about the graph? In the case of graph, we have current, EMF versus time. So what is current, what is EMF, and what is and how to plot this thing? See, if you are making E here, this will be the fixed position of E. E will be always like this. Now check with current. What about the current? If you check about the current will lag behind how much? 90 degree. 90 degree means it will start somewhere here. So it will be somewhere here with current. Okay, why? Because it will start sorry, it will lag. It will lag. Lag means it will be like this. It will start from after 90 degree. After 90 degree means, just see, just understand. This is 0 degree. This is 0 degree. This is 90 degree. This is 180 degree. Here we have 270 degree, and here we have 360 degree. Right? Yes. So when current reaches maximum 90 degree, our current will when EMF reaches 90 degree, our current will comes into the picture, and it will be like this amount. Okay, phase relation, phasor diagram, and graph. Phase relation, phasor diagram, and graph. Then what? Step 5, step 4. Step 4, we have to find. Step 4, we have to find villain. Here villain will be inductance, capacitive inductance. How that will comes into the picture. See this equation. This equation. If you check this equation, we have standard formula I is equal to I naught sine omega t plus minus 5. So here can you conclude I naught is equal to E naught upon omega L? Yes, we can write that. And see, V is equal to IR. That means E is equal to IR. That means R will be equal to E upon I, right? Always remember E upon I will be villain. So if you check here, if your omega L goes here, and if your E naught upon I naught will be here, this ratio will be villain, and that villain will be termed as XL. What is XL? Capacitive inductor. That XL will be capacitive inductance. Okay, this villain is known as inductive reactance or inductance also, you can term it as omega L. And we know what is omega. What is omega? Omega is 2 pi f. So that will be 2 pi f into L. XL will be equal to omega L, and that omega will be equal to 2 pi f. So this will be omega L. Omega will be equal to 2 pi fl. So if you speak about the next step, so our next step will be what? Your next step will be step number 5. And in your step number 5, what you are going to see, you are going to plot villain versus frequency. That is XL into frequency. If you check this thing, XL versus frequency, see, it's too simple. Here we have XL, here we have frequency. See, 2 constant, pi constant, L constant. That means XL is directly proportional to F. If frequency is increasing, XL will be increasing. If frequency is increasing, XL will be increasing. So what you will do, you will write like this. XL versus frequency. Okay, this sign, this straight line will represent that frequency is directly proportional to capacitive inductance. Okay, yeah, inductive reactance. Now heading toward the last step. What is our last step? In the last step, we are going to study about the power. What about the power case? Power is too simple in this case also. See here, power, we have power is equal to V into I. V into I means E into Y. What is E in our case? E will be E naught sine omega t. What about current? Current will be I naught sine omega t minus pi by 2. So this will be equal to what? This will be equal to E naught I naught. And here we have sine omega t. What is sine theta minus 90? That is minus cos theta. Sine 90 minus theta is cos theta. Sine theta minus 90 will be minus cos theta. I will take minus out and I will write cos theta means cos omega t here. If you speak about the average, if you speak about the average, so this will be equal to what? This will be equal to integration of p dt over integration of dt, and that will be 0 to t, that will be 0 to t. So that's therefore your p will be equal to integration of p means E naught I naught will come out of the picture, integration of sine omega t into cos omega t multiply by dt over integration of dt. Integration will lie from 0 to t, it will lie from 0 to t. Just see the catch, just see the catch, just remember the hack. This part will be 0. We don't have to see anything. If this is 0, power will be 0. If this is 0, that means what? That means your power will be 0. If power is 0, that means in inductor circuit there will be no consumption of power. In inductor circuit there will be no consumption of power.